Hello students, in today's video I'll explain about Van't Hoff factor. Okay, in 1886 Van't Hoff proposed this factor to explain the extent of association or dissociation of solute particles in a solution. Okay, so the Van't Hoff factor is indicated with the symbol I, small I. Okay, it is defined as the ratio of observed value of colligative property to the theoretical value of colligative property. You can see I is equals to observed colligative property by normal or theoretical value of colligative property. So this is in case of colligative properties. But if I want to calculate the molecular mass, then small I is equals to normal molecular mass by observed molecular mass. That means it will become reverse of this. So you can see I is equals to normal molecular mass by observed molecular mass. This is because of the reason that molecular mass is inversely proportional to the colligative property. Okay, so now you can see from this we can conclude formula for colligative property. Observed colligative property by normal colligative property is equals to total number of moles or molecules after association or dissociation of solute by total number of solute particles. So normal value is nothing but total number. Okay, normal value comes for total number of solute particles, but observed value is observed after association or dissociation. So we are writing this as total number of molecules after association or dissociation by total number of solute particles. This is for calculating the colligative property. But in case of molecular mass, the same formula gets reversed. Now let us see the Van't Hoff factor calculation for degree of dissociation or association. That means what? By knowing the Van't Hoff factor value, we can calculate the degree of association or dissociation of a solute in a solution. Okay, so first let us see the degree of association. So what is meant by the degree of association? The fraction of total number of solute particles which associate to form a bigger molecule. So already we know what is association. Association means the molecules associates are combines to form a bigger molecule. For example, I am taking n number of A molecules, A solute particles combined to form AN as a bigger molecule. Okay. So here alpha can be the degree of association, and here number of associated moles or associated particles is alpha by n, and number of unassociated, some unassociated particles will be left, no, that is 1 minus alpha. So total number of effective moles of particles in solution, total number of particles in solution is equals to alpha by n plus 1 minus alpha. That means by adding this total, you will get total number of particles in a solution. Okay. So for this, if I want to calculate Van't Hoff factor, Van't Hoff factor is equals to observed colligative property by the normal colligative property is equals to total number of moles after association by total number of moles before association. So total number of moles in a solution after association is 1 minus alpha plus alpha by n. So before association there will be total number of particles, that is equals to unity by 1. So from this we know molecular mass is inversely proportional to the colligative property. So this value will become reversed. Normal molecular mass by observed molecular mass for Van't Hoff factor for molecular mass. So I is equals to normal molecular mass by observed molecular mass is equals to 1 minus alpha plus alpha by n by 1. So the total number of moles after association is equals to 1 minus alpha plus alpha by n. That means what? By using Van't Hoff factor, we are calculating the total number of moles of associated particles in a particular solution. Now let us see about Van't Hoff factor calculation for degree of dissociation. So already we know what is a dissociation. When we add an electrolyte to water or solvent, it gets dissociates, or it will break into different ions. That process is called dissociation. So what is the degree of dissociation? The fraction of total number of molecules which dissociates into simple molecules or ions. This process, the fraction of total molecules which are getting dissociates when you are adding to water or solvent, that is called degree of dissociation. For example, imagine that I am taking A as an electrolyte. When I add it to water or solvent, it is breaking into B, C, D and so on. Okay, so beginning, whatever whatever solute is there, total number of solute molecules before dissociation is equals to unity, that is 1. Degree of dissociation means already we know that is alpha. Okay, so for example, there is a number of undissociated molecules. Actually, some molecules gets dissociated, that can be represented with n alpha, because for each ion I am giving as alpha alpha. So when I add all these, it will become n alpha. But there will be some undissociated molecules or undissociated moles, that is represented with 1 minus alpha. Okay, 1 is total number of moles before dissociation, and 1 minus alpha is number of undissociated molecules. Okay, so from this, total number of effective moles after dissociation in the solution can be given as 1 minus alpha plus n alpha. By adding these two, I am getting this. Okay, so from this, if I take alpha common, I'll get 1 plus n minus 1 into alpha. Okay, so now from this, if I want to calculate Van't Hoff factor formula we know, I is equals to observed colligative property by normal colligative property. So this becomes equals to total number of moles after dissociation by total number of moles before dissociation. So already you know total number of moles after dissociation is nothing but total number of effective moles in the solution. So 1 plus n minus 1 into alpha. And total number of moles before dissociation will become equals to 1. So I am getting the equation 1 plus n minus 1 into alpha by 1. So if I want to calculate Van't Hoff factor for molecular mass, I'll write this formula. I is equals to normal molecular mass by observed molecular mass is equals to 1 plus n minus 1 into alpha by 1. Okay. So from this, the total number of dissociated molecules, the fraction of total number of dissociated molecules or degree of dissociation, alpha is equals to 1 plus n minus 1 into alpha. So finally we got this equation for alpha. So by using Van't Hoff factor, we can calculate degree of dissociation or degree of association. So this is completely about Van't Hoff factor and importance of Van't Hoff factor in calculation of degree of dissociation or degree of association. Thank you so much for watching.